Welcome back to Cosmos in a Pod Space and Astronomy series.
Episode 5.
Today,
Yeah.
Episode 5, we're diving into one of the biggest mysteries in the universe.
Oh, yeah.
Dark energy.
Dark energy.
It's a
big one.
Yeah, it's a concept that really shakes up our understanding of the cosmos.
It really does.
For a long time, we assumed the expansion of the universe,
Right.
first observed by Edwin Hubble,
Hubble, yeah.
would gradually slow down.
You'd think so, right? Because of gravity's pull.
Yeah, you would think.
But then
And something unexpected happened.
something that turned the field of cosmology on its head.
Exactly.
Right.
In 1998.
Oh, wow.
Two independent teams of astronomers were studying distant supernovae.
Okay.
These exploding stars act like cosmic mile markers,
Okay.
allowing us to measure distances across the universe.
I see.
What they found shocked the scientific community.
What was it?
The expansion of the universe wasn't slowing down at all.
Really?
It was speeding up. So instead of the universe's expansion slowing down like a ball rolling uphill,
Yeah.
it's actually accelerating like it's being pushed.
Like it's being pushed. That's the puzzle.
Wow.
And the force behind this acceleration is what we call dark energy.
So dark energy is like this invisible force pushing everything apart.
That's the leading theory.
Hmm.
It's almost like an anti-gravity force,
Okay.
counteracting the pull of gravity,
Right.
causing the universe to expand at an ever-increasing rate.
But if it's invisible, how do we even know it's there?
Yeah, that's the thing.
How did those astronomers make that connection?
Well, we see its effects.
Oh,
It's like trying to understand the wind.
uh-huh.
You can't see the wind itself,
Right.
but you can see how it moves, leaves flags, and even shapes the landscape.
Okay.
Similarly, we can't see dark energy directly,
Right.
but we see its influence on the largest scales of the universe.
I see.
The way galaxies are moving away from each other at an accelerating rate is our clue.
So it's like a cosmic ghost shaping the universe from behind the scenes.
Kind of, yeah.
But what do we actually know about this mysterious force?
Well, we know surprisingly little about its true nature.
Okay.
What we do know is that it makes up a huge portion of the universe,
Like how much?
roughly 68% of its total energy density.
Wow.
Imagine this, the vast majority of what makes up reality is something we can't even detect.
Okay, that's mind-blowing.
Yeah, it's a bit of a head-scratcher.
So we've got this invisible force making up most of the universe and pushing everything apart.
That's the picture we're working with.
It feels like we're missing a big piece of the puzzle.
Definitely.
What are the main ideas out there trying to explain what dark energy could be?
Well, there are two main contenders.
Okay.
First up, we have Einstein's cosmological constant.
Einstein's cosmological constant.
Yeah, now this might sound familiar because it's actually an idea Einstein himself proposed way back in 1917.
Wow, way back then.
At the time, he thought the universe was static,
Okay.
neither expanding nor contracting. To make his equations work with a static universe, he introduced the cosmological constant
I see.
as a kind of anti-gravity force that balanced out the pull of gravity.
Wait, so he invented dark energy before we even knew the universe was expanding?
He introduced the concept,
Wow.
though he didn't call it dark energy back then.
Oh, yeah.
But when Hubble discovered the universe was expanding,
Right.
Einstein abandoned the cosmological constant,
He did.
famously calling it his biggest blunder.
Oh, wow.
The irony is the discovery of dark energy.
Yeah.
The cosmological constant is back on the table.
So maybe Einstein was on to something after all.
It's possible.
Hmm.
In this context, the cosmological constant represents the energy inherent in the fabric of space itself.
Okay.
It's a wild idea.
What is it?
Empty space actually has energy.
Right.
And as the universe expands, more space is created,
Uh-huh.
leading to more of this energy.
Okay.
This, in turn, drives further expansion.
So it's like a self-perpetuating cycle.
Exactly, a kind of runaway train. So option 1 is a constant energy built into space itself,
Right.
driving this relentless expansion.
Okay, what's the other big idea on the table?
The other contender is called quintessence.
Quintessence, okay.
Unlike the cosmological constant, which is unchanging,
Right.
quintessence suggests a dynamic energy field
Okay.
that can vary in strength and distribution across space and time.
Hmm.
Picture it like an energy fluid that's constantly in motion,
Okay.
ebbing and flowing throughout the universe.
So instead of a constant push, we're talking about a force that could be changing,
Yeah,
maybe even getting stronger or weaker over time.
exactly. And this variability could have dramatic consequences for the ultimate fate of the universe.
You're telling me if this force is constantly in flux, It's almost impossible to predict what will happen next, right?
It makes the future of the cosmos a bit of a cosmic mystery.
Yeah, a bit of a mystery.
Which makes you wonder, how do we even study something we can't see or touch?
Right.
It's like trying to solve a puzzle with missing pieces.
That's the challenge with dark energy.
Yeah.
But scientists are incredibly clever when it comes to understanding the universe.
Okay.
We've developed some ingenious methods to study dark energy's effects,
Right.
even if we can't directly observe the force itself.
So what are some of the tricks of the trade when it comes to unraveling this cosmic mystery?
One of the most powerful tools we have is studying those distant supernovae we talked about earlier.
Oh, right, those cosmic mile markers.
Exactly. Remember, these exploding stars act as standard candles,
Right.
meaning we know their intrinsic brightness.
Mm.
By observing how bright they appear to us here on Earth,
Yeah.
we can calculate their distance.
And since light takes time to travel,
Exactly.
the farther away a supernova is, the further back in time we're looking, right?
That's right.
It's like a window into the universe's past.
Precisely by observing supernovae at different distances, we can track how the expansion rate of the universe has changed over billions of years.
Wow.
And it's this historical record that revealed the accelerating expansion.
And pointed us toward the existence of dark energy.
It's amazing how these ancient explosions happening billions of years ago
I know, it's pretty incredible.
can give us clues about the fundamental nature of the universe.
The universe holds so many secrets.
Yeah, it really does.
We also study something called the cosmic microwave background radiation,
Cosmic microwave background radiation.
which is often referred to as the afterglow of the Big Bang.
Okay, the afterglow of the Big Bang.
Imagine the universe just a few 100,000 years after the Big Bang.
Okay.
It was incredibly hot and dense, filled with a sea of particles and radiation.
Wow.
As the universe expanded and cooled, this radiation stretched and cooled too.
So this cosmic microwave background is like a snapshot of the early universe,
Yeah.
a relic from its infancy.
Exactly. And this snapshot contains a wealth of information. By analyzing the subtle patterns and variations in this radiation, we can learn about the universe's composition,
I see.
how much dark energy was present even back then, and how it has influenced the universe's evolution over time.
It makes you realize how interconnected everything is,
It really does.
from the earliest moments of the universe to the present day.
It's all connected.
But these methods you've described sound like they rely on observing incredibly faint signals from billions of light years away.
Yeah, they are pretty faint. How do scientists even do that?
It requires incredibly sophisticated instruments and telescopes.
Right.
Some of the most advanced technology humans have ever built.
Okay, so like what?
Take the Dark Energy Survey, for example.
The Dark Energy Survey. Okay.
It uses a powerful telescope and camera
Uh-huh.
to map the distribution of galaxies across vast stretches of the universe.
So it's not just looking at individual objects.
Right.
It's mapping the large-scale structure of the universe to
Exactly.
see how dark energy has influenced its evolution.
That's the idea.
And there are even more ambitious projects in the works,
Oh, yeah.
like the Euclid Space Telescope and the Vera Rubin Observatory.
Those are going to be game changers.
Yeah, allowing us to study dark energy with even greater precision.
It's like we're constantly pushing the boundaries of what's possible,
We are.
building bigger and better telescopes to peer deeper and deeper into the universe.
And every new observation,
Yeah.
every new measurement
Yeah.
helps us refine our understanding of this mysterious force
Right.
that shapes our cosmic destiny.
But even with all these incredible tools,
Yeah.
there's still so much we don't know.
So much we don't know.
At the end of the day,
Yeah.
we're left with the big question, what's the fate of the universe given this mysterious force driving its expansion?
Right.
I mean, is it going to keep expanding forever?
It's the big question, isn't it?
Yeah. Will it eventually collapse?
Yeah.
What are the options on the table?
Well, depending on what dark energy turns out to be, the universe has a few possible endings.
Okay. Like what?
One scenario is called the Big Freeze.
The big freeze.
Huh?
Okay.
If dark energy continues to dominate and accelerate the universe's expansion indefinitely, galaxies will continue to drift farther and farther apart.
So instead of being clustered together,
Right.
galaxies would become like isolated islands in an ever-expanding sea of space.
Exactly. Eventually, these galaxies would become so far apart that they would effectively be invisible to each other. Stars would burn out, and the universe would become a vast, cold, and dark expanse.
Okay.
A somewhat bleak picture, I'll admit.
It's a little unsettling to imagine everything drifting apart into this cosmic void.
Yeah, it's not the most cheerful thought.
There's another possibility.
Yeah.
perhaps even more dramatic, called the Big Rip.
The Big Rip. Oh, yeah.
If dark energy becomes even stronger over time,
What? Right.
the expansion wouldn't just separate galaxies. It would start to tear apart everything in its path.
That's the idea.
So not just galaxies drifting apart, but everything being ripped to shreds.
In this scenario, galaxies, stars, planets, even atoms themselves, would eventually be torn apart by the overwhelming force of dark energy.
So like the universe would just disintegrate.
It would be the ultimate cosmic unraveling.
Yikes, that sounds intense.
It's a pretty extreme scenario.
So those are the options if dark energy continues to accelerate the expansion.
Those are the two main ones for an ever-expanding universe.
But what if, like, the quintessence theory suggests
Right.
it's not constant?
Yeah.
What if dark energy weakens over time?
Now you're thinking like a cosmologist.
So what happens then?
If dark energy weakens, gravity might regain control.
Okay.
And instead of endless expansion, we might see the universe begin to contract.
So instead of a big freeze or a big rip,
Yeah.
we could see a big crunch?
Precisely in this scenario, the universe would eventually collapse back in on itself,
Wow.
ending in a fiery singularity.
Okay.
A reverse Big Bang, if you will.
It's pretty wild to think that the fate of the entire universe could hinge on the behavior of this mysterious force.
It is, isn't it? It highlights just how profound dark energy is. But its impact goes far beyond cosmology.
Really?
It's forcing us to rethink our most fundamental understanding of physics.
Okay, I'm all ears. How is dark energy shaking up the foundations of physics?
One of the biggest challenges is trying to reconcile Einstein's theory of general relativity,
Right.
which explains gravity, with the principles of quantum mechanics,
Okay.
which governs the realm of the very small, these two pillars of modern physics.
Right, general relativity and quantum mechanics.
Yeah, which have been incredibly successful in explaining so much about the universe.
Yeah, they have.
Seem to clash when it comes to explaining dark energy.
So dark energy is highlighting a potential conflict between our two best theories of the universe.
It's forcing us to confront the possibility that our current understanding might be incomplete.
I see.
Perhaps there's a deeper theory, a more fundamental framework
Yeah.
that can unify general relativity and quantum mechanics
Okay.
and provide a more complete explanation for dark energy.
So instead of seeing it as a problem, maybe dark energy is an opportunity to revolutionize our understanding of the universe.
Exactly. It's a chance to push the boundaries of human knowledge
Yeah.
and potentially unlock entirely new physics.
That's exciting.
It is, who knows, maybe understanding dark energy will lead to new technologies,
Yeah.
new sources of energy, or even new ways to travel through the universe.
It's almost like dark energy is a key
Yeah.
that could unlock a whole new level of understanding about the cosmos.
And that's what makes this field so exciting.
It really is fascinating.
We're at the forefront of a scientific revolution,
Yeah.
trying to solve one of the biggest mysteries in the universe.
It's a humbling thought, realizing how much we still don't know,
It is.
but also inspiring to know that there's so much left to discover.
It really does make you realize there's so much more to learn out there.
Yeah. And for our listeners who share that curiosity and want to explore this topic further,
Yeah.
we'll have links and resources in the show notes.
Oh, that's a good idea.
You can find more information about the latest research, upcoming missions like the Euclid Telescope and the Vera Rubin Observatory, and even some interactive tools to help visualize these complex concepts.
That's a great idea.
It's a great way to continue your own deep dive into the mysteries of dark energy.
I like it, your own deep dive.
And speaking of deep dives,
Yeah.
I have to ask,
Go ahead.
what's one thing about dark energy that really sticks with you?
That's a good question.
What continues to fascinate you about this mystery?
For me, it's the realization that the majority of the universe is made up of something we don't understand.
Wow.
It's a reminder of how much we still have to learn, how much is still out there waiting to be discovered. It's both humbling and incredibly exciting.
I totally agree.
Right.
It's like this cosmic puzzle,
Yeah.
and we're just starting to piece together the edges.
The edges, yeah.
And who knows what incredible discoveries await us as we delve deeper into this mystery.
It's so exciting to think about.
It really is.
Maybe we'll find that dark energy is even stranger and more wonderful than we can currently imagine.
Or maybe it will lead us to a completely new understanding of the universe.
Yeah.
One that rewrites the textbooks
Exactly.
and opens up possibilities we haven't even considered.
It's a journey full of unknowns.
Yeah.
That's what makes it so compelling.
Definitely.
It's a testament to the enduring power of scientific inquiry.
Well said. And for all our listeners out there, whether you're seasoned space enthusiasts or just starting your cosmic journey,
Yes.
remember that the universe is full of wonder and mysteries waiting to be explored.
Absolutely.
So keep asking questions, keep seeking answers,
Keep learning.
and never stop looking up at the stars.
Couldn't agree more.
And on that note, we'd like to thank you for joining us on this deep dive into the enigmatic world of dark energy.
Yes. Thank you for listening.
We hope you've enjoyed the journey.
I hope so too.
Don't forget to follow and subscribe to Cosmos in a Pod for more explorations of the universe and its many mysteries.
And until next time, keep exploring the cosmos.